Mathematica is a powerful computer algebra system. For the purposes of this class, we're going to use Mathematica for communicating mathematical ideas and doing mathematical computations. If you understand how to do mathematical computations in Mathematica, you'll see that using Mathematica simplifies your life. It makes doing computations very easy. With Mathematica, we can concentrate on the concepts behind a problem rather than getting tied down into the minutia of actually doing the problems by hand. I will require that you do some problems by hand, but a lot of problems I'll let you use Mathematica to find the answer. In the problems that I let you use Mathematica to find the answer, what I'm looking for is whether or not you know the right concept, you know the idea behind the problem. The actual computation will be easy. It's up to you to figure out which computation to perform. But sometimes I'll say, show me the steps of doing the problem. I'll say, show how to do this by hand, or show how to do this without using a computer or calculator. And I'll provide some examples of that later on in this lecture. The first thing I want to talk about is a notebook. This is where you do mathematical computations and where you type mathematics in Mathematica. A typical blank notebook or new notebook looks something like this when you first open it. The first thing I want to do is I want to go down here and I want to change the magnification. This 100% means it's at 100% magnification. The font size is too small, at least for me on my computer. So what I like to do is I like to go down here and magnify this. I usually put it at 125% or 150%. This will vary depending on the size of your monitor. I'm on an 11-inch MacBook Air, so I like the font size to be a lot bigger than what the standard system font size is on my computer. But if you have a desktop with a big monitor, maybe you don't need to change the magnification. Now, when you first start typing in Mathematica, you get what's called an input cell. You'll see right here on the right-hand side, this is called a cell bracket. And when you start typing, you're always going to end up in a cell. Everything in Mathematica is a cell. The whole notebook is actually a cell, in fact. Whenever you type, it's always in a cell. And if you're not currently in a cell, when you start typing, it'll create a cell. And then there's these default cells. I've made it so that the default cell is an input cell. An input cell is the type of cell where you do mathematical computations, where you evaluate an expression or solve an equation or do something mathematical. When you want to do a computation, you always do it in an input cell in this class. So you can see the type of cell by clicking on the cell bracket, and you can go up here to Format, and you'll see it says Input is checked right here. And you can change it to a text cell by highlighting text right there. In this class, the only two types of cells that you're going to use are text cells and input cells. You shouldn't really use any other type of cell in this class. When I give you a notebook for like homework problems, I'll use other cell types. But what you give back to me, whatever you type, should always be either in a text cell or an input cell. Another way to create a cell is right here, the cursor is inside the cell. If I want to create a new cell, I just move it down. See how the cursor is vertical right now? But I slide it down and then it turns horizontal. What this means is that the cursor is no longer over the cell. And if I left click, I'll see this thin horizontal gray line. And I can click plus right here. And I can left click on this right here. It says Mathematica Input. And what that means is it'll create a new cell that is an input cell. Here we got an input cell. I'll go down and create another cell. Let's say I want to create a text cell. I can go down here and say plain text. If you decide that you didn't want a plain text cell, you want to change it, you can always go up to Format, Style, and then highlight the cell you want. You can also use the keyboard shortcuts. I use that. But if you don't want to learn that, don't do that. Just do it manually. Just go into Format, Style, change it to Input. Whatever cell you type in should always be an input cell or a text cell. We use a text cell for doing the problem by hand or for writing a sentence and communicating a mathematical idea. You use input cells for doing mathematical computations. I'm going to go ahead and delete these. To delete a cell, I just click on the cell bracket and hit delete. I'm going to go up here and hit delete. I'm going to go back to this input cell. Now suppose I want to do a mathematical computation. Suppose I want to find the value of 3 pi r squared with r equal to 7. So I want to go 3 and then pi r squared. Now, there's no pi button on your computer, so there's two ways to do this. There's actually three ways to do this. One way to do it is to come up here and click on Palettes, and I'm going to click on Basic Math Assistant. And right here, here's a basic calculator, and then if I click on this button, I get an advanced calculator. And it has built-in functions like the log function, log base 10, sine, cosine, tangent, and some other functions, and also like pi, and then e, and then the imaginary I. And it also has these templates for like creating a fraction, square root, nth root, something to a power. So I want to go 3 pi, so I'm going to click on pi right here. And you notice when I leave the cursor over pi, it tells me what the shortcut key is. It's a escape, p, escape. So I can go escape. Actually, I think it's, oh, it is p in Mathematica 9. And there's pi. So let me show you, let me do that one more time. You hit escape, and then hit p, and then it shows me a list of special values. And there's actually, the reason I was confused just a second ago is because in Mathematica 8 it was pi. There's actually two ways to do pi now. So I can go p, so I just click on this and then it'll convert that to a pi. This is a code completion, which is new in Mathematica 9. I go escape, p, and if I want to, it gives me a list of suggestions trying to guess what I want to click in there. If I don't want to use any of the suggestions, I can just hit escape again, and it'll give me that symbol. So escape, p, escape is the pi. Or I can come to the Math Assistant and just click on the pi button on the calculator, and it'll put a pi there. So I want to go 3 pi and then 7 squared. In Mathematica, space indicates multiplication. So I'm going to go space, 7, and then I want to do an exponent 7 squared, so I'm going to click on this superscript, and it gives me a superscript 7 squared. So here's my expression. I want to calculate 3 pi r squared where r was 7. So I've got this expression. I want to know the value of it, so I'm going to hit shift return. In Mathematica, whenever you do a computation in an input cell, to actually execute that command, you do shift return. It's not return, it's shift return. If you just hit return, it's going to create a new line, which we don't need in this problem. So I go shift return, and it gives me the value 147 pi. Now Mathematica always tries to do exact values. So whenever it can do an exact value, Mathematica will give you the exact value. So it tells me that the answer is 147 pi, and it gives me that answer because 3 times 7 squared is 147, and it leaves pi as pi. Now, suppose I want a numerical value for this. I don't want it in the exact answer. I want what this is numerically. Now, what I can do is create a new input cell. So if I start typing, this is going to be an input cell, or I can just manually tell it, create an input cell. And what I'm going to do is I want to take the result of this computation. You see right here where it says out 2, and this is into. Well, this out 2, this means that this is the second value that Mathematica has computed. Now, if I want to use that result, I can go percent. So I hit shift 5 for percent, and I go percent 2. That's the value of the second result. If I hit shift return again, it gives me 147 pi again. Now, if I want the numerical value of this, what I'm going to do is hit n, capital N, and then bracket, and then close bracket. And now it gives me that value to 3 decimal places, and I can increase the precision. And I can increase it even more if I wanted to. And it gives me the command, this is called the predictive interface. It gives me a list of commands that it thinks I might want to compute next. So let's once again do this. Let's do this again. Let's go back to this cell. I want to execute this again. It gives me a value of this result to the precision that the computer is set at, the default precision. I may or may not show you how to change this later on in the class. We're not going to have to mess around too much with decimal expansions. Now, one of the commands it's suggesting that I might want to do, or thinks I might want to do, is increase precision. So I just click on that. I just hit it. and it executes that command. And it tells me the command that it's executing. It did this end command again, and then it has this 20, which indicates that it's going to tell you the answer to 20 decimal places. And then when I did it again, so like here, if I click on the out cell, it says increase precision. I can click on here again. It says increase precision in the predictive interface. I can turn this off by hitting this X right here, and then I can bring it back by hitting the little arrow key. Notice if I want to increase it again and increase it again, and I can manually go in and increase it. I can change that to 320, and there it is to 320 decimal places. I don't really want it to that many decimal places though, so I'm going to delete that. So if I want a numerical answer, what I use is this N command, and it's capital N bracket. Every command in Mathematica begins with a capital letter, and it's delimited by brackets. You always have to use a capital letter. So if I go N and then I said %2, and I hit shift return, notice that this is blue right here. This is indicating that Mathematica does not know what that is, because I haven't defined what N is, and Mathematica doesn't know what lowercase n is. Up here, the capital N was black because Mathematica knows what capital N is. It's a predefined command. So if I hit shift return, it's going to get some nonsense right here, a meaningless answer. That means you did something wrong. So we go back and delete it. So to find a numerical answer, I can hit N bracket %2. And remember, %2 is just the value of the second output. If I wanted to, I could wrap this into an N command. So I could come up here and put N bracket and bracket. And there it gives me to a few decimal places, and I can increase the precision. And there it tells me that the second value right here, this value right here, is controlling how many decimal places. So if I want a numerical answer, I can wrap it into an N command. N means numerical. Now another way to get a numerical answer is, instead of putting integers in my input, I can convert one of these to a decimal place, to a decimal value. So I can put 3.0 times pi times 7 squared. Now, whenever Mathematica sees a decimal in a problem, when it computes a numerical value, it's going to convert everything to a numerical answer. It's not going to give you the exact answer. Now I can hit shift return, and there it gives me the 3 decimal places. Now you'll notice it doesn't ask me, one of the predictions is not increase the number of decimal places on this. Now let's wrap this in an N command. And notice how I increased the number of decimal places and it's not changing. And this is because when I give it a decimal number, it doesn't know the exact answer. And so it's just going to use whatever the machine precision of the machine neuron has. And there's a command where you can change this in Mathematica, but when you put a decimal point in it, it's not going to tell you, it's not going to give you the option of expanding it to more decimal places. If you want to find the value of something to an arbitrary number of decimal places, you need to give it an exact expression. Okay, so if you ever want a numerical answer, just put a decimal in the expression, like we did up here. That's one way to do it. Just hit shift return, it gives you a numerical answer. Only the 3 decimal places in this problem, but it does give you a numerical answer. Or you can wrap it, the exact expression, let me delete these two. You can wrap the exact expression inside an N command and then tell it how many decimal places you want, comma, how many decimal places you want. Hit shift return and it'll give you that number of decimal places. Another thing you can do, let me go ahead and delete most of these cells right here. Another thing you can do, even though I've deleted the cells, in memory, Mathematica knows what like %2 is. It knows the value. Whoops. It knows the value of %2. So I go to shift 2. It still remembers that value, even though I've deleted it here. Now, if I close the notebook and I shut down Mathematica and then I reopen the notebook, you're not going to see any of these in and out because it's not in memory anymore. Once you close Mathematica, whatever was in memory is no longer in memory. It's not going to remember that. So, so if I had something like, um, so if I had something like 3 pi and then 7 squared, whoops. If I had that, and then down here I said percent 22, I did it again, with that. I want percent 22. Mathematica knows this value now, but now if I close the notebook and then reopen it, there'll be this percent 22, but it's not going to know what that is because it's referring, this percent 22 is referring to the 20-second command I did in this session. Once you close it, it no longer makes sense. So I recommend not using this percent too much or relying on it too much, especially if you're going to close the notebook and reopen it. But this is not an important thing right now. The other way to find the value of this expression is to use the freeform input. And this is the lifesaver in Mathematica right now. If you don't know the specific command or you're not used to syntax and you get overwhelmed, it's very easy to get overwhelmed in Mathematica. Always go to freeform input or something called freeform input. To get that, what I can do is I click on this plus sign right here. I want to create a new cell. So like if I'm right here, I want to create a new cell. So I just come down here and left click. I'm going to create a new cell. I'm going to choose freeform input, or you can do a Wolfram Alpha query. Now, a freeform input is you have to be connected to the internet. It's going to make a call to wolframalpha.com and do a computation. So I can go 3 pi 7 squared. You just type it like you would normally type mathematics. You don't need to know syntax for the freeform input. That's the nice thing about it. Now I don't hit shift return. I just hit return for freeform input. Just hit return, not shift return. It's very important that you don't hit shift return. And so I just hit return, and there it is. Now it gives me the exact answer, and it tells me what it thinks I wanted to compute in Mathematica syntax. 3 star pi, capital PI, star 7 squared. Now I can click on this to say show all results. I'm going to click on that. And since it is making a call to Wolfram Alpha, there's a little delay. And then down here we see decimal approximation. And I can just click on that. And just select that input. And then this will, it gives me the answer of that input right here. Now right here it says this, if I had the cursor on it, it says this input is selected, press shift enter to evaluate this input. So I'm going to hit shift return. And there it gave me the value of that command. So it'll give you a lot of stuff when you say, give me all the information from Wolfram Alpha. It normally gives you a bunch of stuff. And so sometimes you have to hunt and peck for it. But you hit that shift return, and it does give you the output. And you can use that output using that percent 25 if you want to use it. Like percent 25. I did that again. It's percent, not command percent. So it's percent 25. I could say divide this by some number, and it knows that value. Because when I said execute it puts it in memory. It gives me the output of that. This Wolfram Alpha, this freeform input is a lifesaver. It makes using Mathematica very easy. It tells you the actual command. I just have to type it the way it is, or I can copy it. I believe there's the option of copying it. And so there's really no excuse not to know how to do commands in Mathematica. You can always use the freeform input. I'll never say don't use freeform input. Now, the nice thing about the freeform input, I'm going to go ahead and delete all of this. The nice thing about the freeform input is I can use it while doing a computation. So suppose I want to find the value of 3 natural log 7. Well, I'm going to go 3. Well, I don't know the command for, let's say I don't know the command for natural log in Mathematica. It's not ln like you would think it is. It's actually log. Well, what I can do is I can come up here, insert, inline freeform input. On the Mac, it's going to be control equals. So I just do this right here. So you notice how the 3 is outside that box. So I'm going to inline, I'm going to do a freeform input. And I'm just going to type natural log of 7 and hit return. Not shift return, but just hit return. And then Mathematica tells me what it thinks is the actual command I want to compute, which is log 7. Capital LOG is natural log in Mathematica. And now I can hit shift return, gives me the value. If I want the numerical answer, I can just hit numerical value. And then I can increase the precision if I want to do that. Now, if I wanted to do 3 log base 5 of 7, then I can type, I'm going to go to a new cell. So just come down here, type 3, and now I'm going to do control equals on the Mac. I don't know what it is on Windows, but on the Mac it's control equals. So this is or you can go to insert, inline freeform input, and I'm going to go log base 3 of 7. Oh, let's say log base 5 of 7, that's what I originally said. And I just hit return, and it tells me what it thinks the command is, and this is actually correct. That is the way to type in log base 5 of 7 in Mathematica. So this is very nice. You don't need to know the syntax with the freeform input. You can just type it the way you want to say it. That's the whole idea behind the freeform input. You type things the way you say it in English, and then it makes a very good guess about what you really want. And usually it's correct, unless you really type something goofy. So now I can hit shift return, and there's the value, and then I can get the numerical value by hitting numerical value. So use the freeform input if you get stuck in Mathematica. Another thing I want to say is, I'm going to go down here to typesetting in this palette. If you're going to type a fraction, you want to execute a fractional command, then if you want to evaluate a fraction, type it the way you would write it on a piece of paper. So over here, I'm going to go to this fraction key right here, and it creates the template for the fraction, and I can put 5.6 star if you want pi, and then down here I can go divide by, say if I want to do 3.908, then hit shift return, gives me the answer. Type things in the input the way you would write it on paper. Use the templates down here. Use the typesetting templates to do a fraction. This is for a fraction. If I want to do an exponent, I use this one right here. Subscript is this key right here, and then the other one that we're going to use probably a lot would be radicals, and this would be like nth root. So like if I wanted to do the 5th root of 7, I'd go 7. And then come over here and change that to a 5. This is the 5th root of 7. And if I want the numerical answer, I just do that. It gives me the numerical result. So in typing mathematics, type it the way you would write it on paper, and use the palette to do that. When you get really comfortable with it, you'll use keyboard shortcuts. Like for the superscript, for like exponent, you would use Control-6, at least on the Mac. I believe it's the same on Windows and on Linux. Okay, so this is the basics of doing a computation. I'm gonna go ahead and delete all of these now, and I'm gonna get rid of this palette. And I have some examples that I had pre-created. I'm gonna give you some examples of what a typical homework notebook will look like. Usually there'll be a title, so let me just go ahead and put a title here. You don't need to mess with any of this stuff. Again, the only thing you're going to use are input cells and text cells. So you notice how it's got this funny little cell bracket right here. This indicates that this is something that can be expanded. There's stuff underneath this that I hid it. So I'm just going to left click on it twice, so double click on it. And here I've got some problems posted. So I'm going to go through and do these problems, give you an idea of how to use Mathematica. So here it says problem 1, find the 4th decimal in the decimal expansion of this. Now notice that here's the bracket for problem 1. Typically on the notebooks that you're going to get for homework assignments, I'm not going to have the cell brackets for problems. Like for problem 1, this will not be there because I don't want people to delete it or mess with it with the problems. But even if it's not there, it's always there. It's just hidden. It's just not showing in the notebooks that I'll be giving you. Now I want to type something, so what I'm going to do right here Notice the cursor is in the cell, so if I type, it's going to be in the cell. So I need to move it down until it becomes horizontal there. Now I left click. Now I'm ready to do an input. And I can either convert this to a text cell or I can just use the default, which is an input cell. Now I want to do the decimal expansion of 3 pi over 2. So I'm just going to type parentheses 3. And I can use the palette if you want, but remember it's escape P. I'll just use the code completion to give me the pi. Close parentheses, divide by 2. Hit shift return. And then I want this as a generic number. So it says assuming an angle, but now it says assume as a generic number instead. I'm going to hit that, and then I'm going to hit numerical value. It says the fourth decimal in the expansion. So 1, 2, 3, 4. The fourth decimal is 3. So now I want to type this. This is the answer to the problem. So I'm going to convert this to a text cell, plain text. The fourth decimal is 3. And notice the font difference. Right here in the input cell, you'll get this bold font. In the text cell, it's not bold. It's just a normal font. Now in problem 2, we want to find the value of this expression. So I'm just going to come down, and I created an input cell. Normally I'll give you an input cell and a text cell by default underneath the problem, and I had already put it here. But if I don't do that, if there's nothing there, then you just have to create the cell yourself. But usually I'll always put a cell there. And I just type in the expression. Just type it in as you see it, minus 4.12. Now divided by, so I'm going to use that key for the division, minus 2.103. Hit shift return, it gives me the answer. Now in problem 3, I want to find this value. This is a different problem than problem 2 because in problem 2, the only thing being divided is this part right here. In problem 3, I have to first do the numerator part, then do the denominator, and then do the division. So in problem 3, if I'm going to type it out, I have to use the parentheses, 3.709 minus 4.12, then divide by 1.89, parentheses 1.89, minus 2.103, and then hit shift return. So you have to know the order of operations. And if you don't know the order of operations, well, that's bad. I don't want to know if you don't know the order of operations. Use the palette to type it the way you see it. So I can come over here and get this palette, and I could have created a fraction, and then I could have typed it in as I see it. There we go. And hit shift return. So type it the way you see it, or understand the order of operations. Understand how the order that things are being evaluated in. Let me close this palette. Now in problem 4, I want to find 4 log base 5 of 7.26. I don't know the actual command for log. Well, actually I do, but I'm assuming you don't remember it, even though I talked about it earlier. So I'm going to use the freeform input. So that's going to be, let me get a freeform input. To freeform input, the shortcut for it is to just type equals when you're at an input cell. So here's the freeform input. So I'm just going to type in, outside of, actually I wanted to go 4 times, and then the freeform input. So I'm going to go log base 5 of 7.26. Hit return. I'm going to click on that. That's the actual Mathematica command. I'm going to hit shift return to evaluate that. That's the answer. Okay, in problem 5, it says the volume of a cylinder is given by the formula V equals pi r squared h. Find the volume of a cylinder radius 3.29 and height 17.4. Now I'm going to show you the real power of Mathematica. I'm actually going to create a function for this formula right here. So this is important to pay attention to right here. You can't do this. You cannot use your own defined functions in the freeform input. It won't work. So what I'm going to do is I'm going to create a function. I'm going to go Shift V, because I'm going to use capital V because for volume. Notice how it's blue. That means Mathematica does not know what capital V is. So if you ever do something and it's black, like N, that means it's already built in. You can't use that letter. So Shift V for capital volume. I'm going to go bracket, and then the variables are R and H. So I'm going to go R underscore, comma, H underscore. So I'm telling Mathematica I'm creating a function that I'm going to call V, and it's going to take in two letters, R and H. R for radius and H for height. Mathematica doesn't know what you mean by R and H, but you're telling it you're going to use these two symbols, R and H. And then I'm going to go colon equals. It's not equals, it's colon equals. Very important you have colon equals. And then I just type in this formula. I go escape P, get my pi, space R squared. That's R squared, and then space for H. You have to, when you have letters, you have to have a space between them. Like you can't, if you're gonna have RH, you can't type it like that, because Mathematica will think that RH itself combined together is one symbol. You need a space to indicate multiplication. You'll notice how they're green. It's expecting R and H as inputs, so when you use them on the right-hand side of the colon equals, it should be green. If it's blue, it means Mathematica doesn't know what you're doing. If you forget putting a space, then just use manually type in multiplication, which is the asterisk. You get R H. So in this problem we have R squared. I'm going to go space H. So I've defined a function. This is a once I define a function, I don't need to define it again within this session. So here's my volume function, and it says find the volume. The radius is 3.29 and the height is 17.4. So to find it, I just create an input cell, and I go V of 3.29, comma 17.4. Now pay attention to the order of the inputs. The first letter has to be radius, and the second letter has to be height. If I switch this, I'm going to get the wrong answer. So whenever you use a function, you have to be consistent with the way you define it. Just keep that in mind. So now I'm going to hit Shift Return, and there it gives me the value of the volume. Now in problem 6, it says the volume of a cylinder is 802.56 cubic inches. The height of the cylinder is 27 inches. Find the radius. Now, if you go back to this formula right here, I know what V is, and I know what H is in this problem. I don't know what R is. So what I'm going to do is I need to solve an equation. If you were to type this out, you would have, or to write it out on a sheet of paper, I'll go ahead and type it. You would have the equation 802.56 equals, and then pi R squared, and then H, which is 27. And then you'd want to solve that equation for R. Well, we don't need to type all that. We have this function defined, V. So what we need to do is solve this equation. Symbolically, using function notation, the equation we're trying to solve is this one. I'm going to go solve, and let me show this. I'm going to go capital S for solve. Every command in Mathematica begins with a capital letter. Solve. When I type in SO, it gives me a list of functions that I may want to use. So I'm going to click on solve. Now I'm going to click on this arrow right here, and it's going to give me a template. Which template do I want to use? And I'm going to use this first one. And then I just type in the equation I want to solve, and then the variables I'm solving, the variable I'm solving for. Well, the equation I'm going to solve is V of R, comma 27. I know the height, so equals, the volume is 802.56. When you solve an equation in Mathematica, you have to use equals. It's not single equals. Single equals in computer or programming languages means you're assigning a value to something, or you're setting a variable to this value. It's not an equation. Equals in Mathematica is an equation. And then I'm going to type in R. I'm solving for R. And then I hit Shift Return. And there it gives me the two answers, minus 3.07597 and then positive 3.07597. So the answer in this problem would be 3.07597. So I'd create a text cell, and I would say the answer, the radius is 3.07597 inches. So I typed the answer that way. So notice how this is very easy. I don't need to type out the whole problem. I'm just solving this equation. This is the power of Mathematica. This is why I like to use it, because now I can ask questions where I know exactly, I can determine exactly what you do or don't understand about a problem. This, if you're not used to it, this is the equation you're solving in function notation. This is the power of function notation, and this is something that we'll be seeing over and over again. So if you're not comfortable with this right now, that's okay. We'll be covering it as we progress in the class. Okay, so now in this next problem, it says find the vertex of this parabola. So I'm going to create a function. So I'm going to type in f of x, underscore after the x, not a space, but x, and then underscore, close bracket, colon equals, and then pi x squared, so x squared minus 4 times x, I put a space, minus 1, shift return. There I've defined my function. If I want to find the vertex of a parabola, I'm going to go brace. The vertex of a parabola is minus b over 2a. So I had to put this in parentheses. 2a is 2 times pi. If you don't put it in parentheses, it's wrong. You'll be computing 4 divided by 2 times pi, which is not the same thing as 4 divided by 2 pi. Or use the palette and put it in the fraction symbol, so you don't make that mistake. And then f of that value. So I'm going to go ahead and use the fraction symbol. 4 divided by 2, and then pi. And then close bracket, and then close brace, and then hit shift return. And there it gives me the exact value. It gives me it's 2 over pi is the x coordinate, and then minus 1 minus 4 over pi is the y coordinate. See, we already defined f. I don't need to define f again, and I can use it for computations later on. I can use it later on in the computations I'll be doing in the notebook. Now, if I close the notebook and I open it, it's not going to know what f is, so I'd have to go back here to use f. I'd have to hit shift return again in order to put it in memory. Whenever you close the notebook, whatever's in memory is gone. So you may need to re-execute commands. So like in particular for functions. So if you do a problem and then you had to go do something, you save the notebook and close it. When you come back, you may have to re-execute the function command so Mathematica knows what that symbol is now. Now in problem 8 it says find the x-intercepts. I'm going to use, instead of using solve, I'm going to use nsolve. Solve always tries to do exact value. I just want numerical approximation. So I'm going to go nsolve. And notice I type n capital S. It gives me nsolve is one of the options to use. This is the code completion that they have in version 9 and higher. So now I'm going to click on this. And then I'm going to click on this little arrow right here. And I just want to solve an equation with a variable, so I click on this first one. And so now I'm going to type in the equation, and x-intercept is obtained by solving the equation f of x. So f of x equals 0. And I'm going to solve this for x. And I hit shift return. And there it tells me the x values of the x-intercepts. So to answer the question, I go down here to a text cell, and I just write the x-intercepts. Of course, x-intercepts are ordered pairs, so I'm going to get minus 0.214024, and then f of that value, but I don't know what f is, so I'm going to come up here in an input, I'm going to go f of that value. I'm going to highlight this, copy it, and then paste it. And it'll give me this, do I want to paste literal, whatever, I just hit OK. It makes an interpretation of what I'm looking for. F of that is 0, which of course has to be true because we're finding the x-intercepts. This is the values of x that make the y coordinate 0. So I go 0, and then I go For the next one, which would be 1.48726, comma 0, you can plug it in and verify it. I don't need to. So there are the x-intercepts. X-intercepts are ordered pairs. Now in problem 9 it says plot the graph of the parabola. There are two ways to do this. One way is to just type f of x, hit shift return, and then right here in the predictive interface it says plot. Do I want to plot this expression? So I hit plot, and there it gives me the plot. And this is the actual plot command. Plot is the word plot with a capital P and then delimited by brackets. My range values for x are given right here. This is the left-hand value, and this is the right-hand value. You can go in here and change this. I can change that to 18 if I want, and I could change this to minus 17 if I wanted. And there it changes the range of values that I'm plotting this, the range of values for x that I'm plotting this in. In another lecture, I'll show you how to do more sophisticated stuff with the plot command, but for right now, this will suffice. So you don't need to know the actual syntax. You can just use the predictive interface, and it'll plot the function for you. And you can go in here and manipulate it and change it accordingly. If you wanted to use the notation f of x, you could just erase that and type in f of x. The actual command is plot. Let me just go ahead and go plot. I use the code completion, go plot, click on that arrow. I just want to plot a single function, not multiple functions, so I just click on this one, and it gives me the template. So I type f of x, and then x, smallest value, largest value. And there I get the plot of the function. In problem 10, I want to graph an equation in two variables. So what I'm going to do is I'm going to get this freeform input, and I'm just going to type in plot. The actual command for plotting a function of two variables is complicated. But is not what you think it is. Let me put it that way. Minus x plus 1. So notice in the freeform input, I only need to put a single equals. I don't need to put equals equals. I just hit return, and then it tells me the command that thinks I want to compute or to execute, and I just hit shift return, and there I get a plot of this equation. In problem 11 it says solve this equation without using a computer or calculator. So when I write that, that means don't do any computations, just type out in plain text. So use the palettes, type it relatively neat. So I'm just going to go natural log of 3x minus 1 minus natural log of x equals 2. In the next line, the way you solve this equation, you combine the natural logs. So I get natural log. I'm going to have a space between those lines. I'm going to get natural log of, I'm going to put a fraction there, 3x minus 1 divided by x equals 2. You see this yellow box, I want to get out of that. Then I'm going to go down. And then when I do the next step, the way to get rid of the natural log is to raise e to both sides. So I'm going to end up with 3x minus 1 over x equals e squared. So I'm going to get 3x minus 1. I'm going to get 3x minus 1 equals e squared times x. And then I put all the x's on one side, so I'm going to get minus 1 equals e squared x minus 3x. Now I factor out the x, so I get minus 1 equals e squared minus 3 times x. And then finally I get, as my answer, minus 1 e squared minus 3 equals x. Oops. And that's the answer. In the problems that I ask you to type the answers, I'll try to make them short problems, easy problems. Just want to know if you actually know the steps to it. In the more complicated problems, you'll always be allowed to use the computer. Okay, so this was a rapid introduction to Mathematica. You may need to watch this more than once, maybe even several times, or refer back to it. The main points that I want to get across are how to operate with the cells, how to delete a cell, how to type mathematics, how to do basic computations. You definitely need to know how to define a function. We'll be doing this over and over in the course. So even if you're rusty on it right now, you'll get enough practice that you'll be very good at it by the end of the class. And also, I want you to know, very importantly, the difference between an input cell and a text cell. When you're typing mathematics as an answer, you use a text cell. It should look something like this. When you're doing a computation in Mathematica, you use input cells. It looks something like this. Key points to execute a command in Mathematica: always use Shift-Enter. Use the free-form input. If you don't know something, just type it as you would say it, and Mathematica will usually guess correctly. And then two things I didn't mention. In each input cell, only do one command. Don't do a plot and then try to evaluate something. In each cell, there should be only one command. There should not be multiple commands. You'll mess things up if you try to put multiple commands. So if you want to do another operation, you just create a new cell and then do that operation. Whatever you want to do. Each input cell should have exactly one computation. Don't do more than one computation. The last thing I want to say is Mathematica has a lot of keyboard shortcuts, which is a good thing, but then the bad thing is if you do something, you press keys, you can crash the system. It is a little prone to crashing, more so than I would like. So I highly, highly recommend that after each problem you save the notebook, so that if it does crash, you only lose at most one problem. After every problem, you should always save the notebook. I can't emphasize enough. Save the notebook. It's a keyboard shortcut. It's Control S on Windows, I believe, and it's Command S on Macs. So I just constantly save it as I go along, and you should do the same thing too. If you have any questions, feel free to ask me. Post in the discussion board. Send an email. If you post questions in the discussion board or send me an email, you have a question on a Mathematica notebook or a problem, always include the notebook. I will not answer anything that does not include the notebook you're working on. It's too difficult to explain this in typing, to explain what you're doing or trying to do or what your problem is. You must always include the notebook when you ask a question on it. I'm willing to answer any question on Mathematica, so feel free to contact me about using Mathematica. It can be very daunting at the beginning to use it. It's really not that complicated. It's really not that complicated to do computations because you can always use the free-form input. Make use of that. It's a very useful tool in Mathematica. If you do know the actual commands, you'll be a lot faster than if you use free-form input. Outside of defining a function, there really isn't anything you have to know the command for. You can do everything in the free-form input. But I recommend getting used to the syntax a bit and trying to learn the actual commands. The focus I want to focus on in the class is focusing on which computation will solve the problem that is being asked. I'm not so concerned on the steps of doing the computation. I will ask those questions, but my main focus is when I ask you a question, do you know what computation needs to be done? Not so focused on how you do that actual computation, but there will be problems like that.